Hello guys, this is the data structures and algorithms tutorial series, and today is the lecture number 2, and our topic is complexity of an algorithm in this lecture. Myself, Dr. Dibojyoti Bora. So today's lecture topic is complexity of an algorithm. First of all, definition of complexity. So what do you exactly mean by complexity? Complexity of an algorithm is a measure of the amount of time n or space required by an algorithm for an input of the given size, say n. So what does the definition say? The definition says that exactly how much time that algorithm will take for an input of size n, or how much space it will require to execute the same for the given input size of n. So two things you have to notice, that complexity is totally depending on one thing, that is input of the given size, and it is measured either in terms of time or in terms of space. So accordingly, we have types of complexity as two types. First is time complexity and other is space complexity. In case of time complexity, running time of a program as a function of the size of the input. So in time complexity, what we do exactly? We try to measure the algorithm by a function that will be the exactly taking the input as the size of the input provided and how much time it takes to execute the total algorithm steps. Clear? Then space complexity means what? In case of space complexity, the analysis will be done based on how much space that algorithm needs to complete its tasks. Clear? So time means the exact amount of time needed to complete all the steps involved in that algorithm, and space, exact amount of space needed to complete the tasks for which the algorithm is designed. But you know, this space complexity is important only when we have less space in our system. And so this was very critical and very important only in the early days of computing. As you know, at that time, storage space of the computer was very limited. At that time, even 1 KB is also very important for us. But you know, nowadays, our storage space is really growing actually with no limit. No limit in the sense if we compare it to the same of the earlier time. So nowadays, the space complexity actually is not concerning to us, and is the time complexity. So nowadays, only the time complexity matters. As you know, time complexity gives us the analysis on the basis of the time taken by the algorithm to complete all the steps for the given input, that is of size say n. Clear? So we'll focus on time complexity, then space complexity. Now, what do we exactly measure through this complexity? Just giving you an example. Suppose if you go for buying potato, then what would happen? Either you will buy 1 kg or half kg or like that. That 1 kg is the matrix by which you are exactly getting those number of potato that will together containing the weight as 1 kilogram, isn't it? So that kg is what exactly working as a metric for that weight, isn't it? So here also through complexity we try to measure the algorithm, we try to analyze an algorithm, and in analyzing that algorithm, rather than a piece of code, we'll try and predict the number of times the principal activity of that algorithm is performed. What I have said, principal activity of that algorithm. Principal activity means what? For which problem exactly we are designing that algorithm. Suppose we have designed an algorithm to solve a quadratic equation, then what will be the principal part in that algorithm? To measure the time involved to compute the discriminant, isn't it? Similarly, if I am going to give other examples, let's take the first one. If we are analyzing a sorting algorithm, we might count the number of comparisons performed. At this stage, maybe this statement is not clear to you because I have not yet framed a lecture for sorting algorithm. Obviously, I'll do in the coming session. Okay, so do note that sorting means, suppose you have been given some numbers like 5, 2, 7, 8. Okay, now you need to arrange it either increasing order or decreasing order, means ascending or descending. So we may arrange it 1, 5, 9, 10 or 10, 9, 5, 1. So that is a kind of common sorting, and in sorting the main principal activity is the comparisons. We need to perform comparisons among the elements. First one is clear. Then second is that if it is an algorithm to find some optimal solution, the number of times it evaluates a solution. So if it is a case for finding some optimal solution, you can think this term optimal as a best solution, then we have to concern with the number of times it evaluates a solution. Then if it is a graph coloring algorithm, it is very, very important. So my friends, graph coloring algorithm I'll cover, of course, in some extra lecture, because this is very important. And there we might count the number of times we check that a colored node is comparable with its neighbors. What the main important part in case of coloring, graph coloring problem, is that we need to compare that particular node with its neighbors, and that is the principal task here. That is the number of times we check that a colored node is compatible with its neighbors. Clear? So these are the reason actually why we need to measure algorithm, and what we do measure complexity of an algorithm. Clear? So, but when going for that measuring tasks, so we need complexity, but in that case also, what happens? There will be 3 different cases. You know, 3 different cases means either worst case or best case or average case. Worst case means, suppose in a condition you are trying to choose a number, say 5 among 100 different numbers, then you will try to compare your number, say that is the 5 in this case, from the first element to the 100th element. If it is found in the first element itself, then what will be the case here? Yeah, you are correct. That is the best case. Why? Because we have found the element that we are searching at the first step. We don't go for the other comparative analysis step, isn't it? But what happens if I have found that element at 100th location? Then we need to perform those number of comparisons. Okay, we need to compare with every element, that is 100 elements, to find our element to be exactly its location at 100th place, isn't it? And that is the worst case here. And average case means the number will be found in between them, in between best case and worst case. Clear? So now coming to the definition wise, worst case means in this case the analysis process considers the maximum number of steps taken on any instance of size n. Now it is very clear to you. Then best case means in this case the analysis process considers the minimum number of steps taken on any instance of size n. This is now also clear to you. Then average case means the analysis process considers the average number of steps taken on any instance of size n. So worst case, best case, average case, you will find everywhere when you try to find out the complexity of an algorithm. So this is very important. So guys, In this lecture, we have gone through the definition of complexity and then types of complexity, then why we do measure and what we do measure in complexity, then 3 different cases of complexity. If you guys like this video, then of course do subscribe to my channel and share and like with your friends. Okay, so we'll meet in the next lecture. This is lecture number 3. Till then, take care. Bye bye.